So here we are in the VCL, and we want to play with RStudio. So we're going to click on RStudio. First we're going to make it so we can see the file extensions. Okay, just as usual. And now I'm going to be able to see everything that I want to see. I'm going to open R, and I'm going to read in my file. So I'm going to actually, before I do that, I'm going to create a new R script. So I'm going to say File, New File, R script. And I'm going to be able to type in here. I'm going to save it as, and I can just say like wherever I want it to go, which is like the desktop right now. I'd rather have it there so I can find it and save it. And it should show up. Okay, it didn't show up. I don't know why. Save as. I don't think I went to the desktop. Okay, there we go. Now I can see it. You know, computers are weird sometimes. You kind of knew that. Okay, so we've got our file. Right now it's empty. And now I'm going to import my data set. And so I'm going to say File, Import Data Set from here. And I'm going to Computer. And you're going to find it wherever you find it, and I'm just going to import my data set from wherever I import it from, which is somewhere else. Actually, I want to use a different data set. I want to use this one. But you're going to import a CSV. It should show you the data, and you can change this disgusting name. You can make it something else. I'm going to call it my data. There we go. And so then I'm going to look, and so my other file that I'm trying to write is hidden behind the data set, and it's going to show me, if I look at the console, it's hard to see everything. I need to save that file that told me how to read in my data. I'm having trouble seeing everything I need to see here. Gotta stretch this out a little more. Ah, there it is. I don't know how that got hidden. Okay, I don't need the view my data because this is why I'm viewing it, because the computer told it to view. That I don't really care about that right now. I might need it sometime, but not right now. So I need this particular line. I want to save this. So I need to first make some comments. Here's my name. Homework number R, homework on R. Okay, so I'm going to save that. Hit Control S, hopefully that'll save. And I'm going to go back to my work. Okay, so right now I only have one useful line in my RStudio file. I'm going to close this down and make sure this works. I'm not going to save my session. I'm only gonna work off of my .r file. It's called a script. Okay, so we're gonna try launching off of this script. I'm gonna say open, and I have to search for a program. But luckily, I only have one in my list of choices. And now that I've done that once, then for this session, the VCL will recognize that I want that to be an R file. Okay. So it doesn't automatically run, it just loaded it. So what I can do is I can click on this run button, and it's gonna, well, I think it's gonna run. Maybe I have to put my mouse here, I don't know. There we go. That looks like we got the data in now. Okay, so if you don't like the name of your data, you could change it. You could say, I'm gonna call it data. now I have two names for the same thing. Well, actually I have two copies of the same thing, and since I'm not going to change anything, then they'll stay identical, but I could change one and leave the other one the same. So for example, let me show you some cool things about this. First of all, if I say, for example, assign, so this symbol right here is an assignment statement, is less than and then minus. Less than followed by minus, no space. So v less than minus 8 means put an 8 into the variable name v. And if I want, I could have a string. I could do the same thing. So put the string Donna into the variable name called name. I'm going to change v to be a vector. So the letter C means concatenate. So I want to concatenate 4, 12, and 32, and that creates a vector. If I just want one of those elements back, I can just ask for individual elements back. If I type ls, it tells me everything that I have in my variable namespace. But I also, since I'm using RStudio and not regular old R, I have access to my variable space up here in this window. You can adjust the sizes of these various windows to your satisfaction. Okay, so some things you might want to see. If you just type my data, it's only going to print out some of your data, so you get a sense for what it looks like. And so if you really wanted to see your data, you'd probably use the view command. What if you just want the names at the top of your data? You could do it this way. If you want to know the length of the data, you can do it this way. It tells you actually, and you could do the other dimensions too. This tells you that the data, there's 503 observations across 20 different things that you were observing. Okay, so you can do mean of the exposure column by typing it this way. So I could do the mean of just about anything I want. I could do mean of the C column. That would work. And since I've coded up males and females as zeros and ones, I can already find the proportion of males and females. So actually it's 40% male, because I used 1 for males, so 40% males and about 60% females, roughly. Okay. I have median of the males column, which means that the typical person was female. But we kind of knew that because we knew that 40% of the people were male, so that's not surprising. Okay, now there's no built-in mode that I could find. You can just figure out the mode if you are willing to write 3 lines of code, or if you want, you can look up a package. If you're going to be importing a package that has mode anyway, you might as well do that. But I don't require you to use mode for this homework because it's kind of a pain to figure that out. Also, you should know na.rm equals t is often an option you have to use if, for example, you're trying to figure out the median or the mean of some data and there are some missing data points. So you have to do that to get around the fact that missing data is coded as NA, and so you want it dropped out of your calculations. So for example, if you have missing data in your exposure column, you would code it up this way. We happen to not have any missing data because, well, we would have cleaned it out. But if we did have missing data, then this is how we would deal with that problem, and then it would calculate the mean for us. Whereas if there were missing data and we didn't put that flag in, it would just choke on us. So it's good to know that, especially if it comes up in your project. Okay? Now we're going to create a matrix just to have fun with it. This is not that exciting. We're not going to have header names or row columns. We're just going to make a really very simplistic matrix. And the first row is going to be 1, 2, 3, and the next row is 4, 7, 9, and the next row is 1, 2, 1. And I'm going to just type it in that way. So now I can see specific elements if I select them. And that's how I would do that. Okay, so we've got a way of accessing a specific element of the matrix. Now I wanted to show you what happens if you have two copies of the same matrix. Or, yeah, that makes sense. So right now they look the same. I'm going to change one of them. I'm going to say the first element, I'm going to make it 0. Now what happens? So we've made the first element 0, but what about my matrix? It's still the same. So that means we've made a deep copy. When we created a second copy of our data, we created a deep copy. So this is good because sometimes we might want to save one and change the other one. Okay. Next, I want you to know what this does. Something like this. What do you think this does? So what it's doing is it's starting at position at 0 and it's marching up to value 10. This 2 means how big the step size is. So you could do something like this. You could say something silly like that. So if you say 0 to 100 stepping by 25, then you're just counting by 25s. Okay? So you can count by 0.1 or you can count by anything you want. So now this should make a little more sense. We want quantile of my data on the exposure column, but the cut points we're going to use, we're going to use, if we want a 5-number summary, we want to count by 0.25, and so they're calling it probabilities, or we're actually doing percentiles or quantiles. You could choose 0.1 if you want to break it up every 10%. So you have full control over that, and it's just sort of, it's like a slice of a QQ plot. So you can pick any percentiles you want. Okay. You can do histograms. And one thing I wanted to point out here is that this is kind of small and ugly. If you just export it, or if you do a screenshot, it's not very good. So you can save the image, and then if you change the height and the width, then, or you could just maintain aspect ratio and just change one of these two, then you'll get a much better picture. So if you're going to be saving off these pictures for presentation, you should do that. Don't just grab this tiny little piece off of the screen because it's kind of tiny and gross. Also, hold on a second. Okay, sorry about that. Alright, so that's about how to make a nice histogram. So maybe we want some box plots. I don't know why this is a problem. Because I didn't recode it. I did not yet recode it, so it can't do that. If I wait until after I recode it, then it will tell me the gender is male or female, but I haven't done that step yet. You know that I like to do that. But again, this is kind of a pathetic looking diagram, so I would save it. Okay, save it as an image and then change these things. Let me just go ahead and do that and show you what it looks like. Okay, it didn't work as I expected. Well, there you go. So it did save it correctly. Okay, so let's see what else. What about correlation? It will tell you correlation. What if I do a correlation of 3 things? I guess it doesn't want to do that. Okay, well, too bad. That's pretty pathetic. But anyway, sorry about that. There's some things I don't like as much about R than is in some other languages. And I guess that's one of them. I just found another thing I don't like about R. Because, you know, most software would figure out what I wanted and not R. R doesn't like to make anything easy for me. Okay, there's the variance of the C column and the standard deviation of the C column. Now what about pie charts? Pie charts I want to show you on 2 different systems because the virtual machine does a really bad job. This RStudio version, it does a really pathetic job at making these pie charts. So, but let's go ahead and see how to do it. Whoops. Okay, so I've got some labels and I have a table and I'm just going to say pie, my table, my labels, and main is just going to give me a title. Okay, so this is just not that nice. I mean, maybe it's okay, it's acceptable. I can save as an image, but maybe I want it to be bigger, and so I'm going to make it like that. I don't know. So now did it do a good job? I don't think so. It's okay. It's better than it was earlier today. I'm not really sure why. But I'm going to show you what it looks like on my computer, and I'm running R. You can see I just typed the letter R at my command line and it's already installed, so it came up, and I've loaded the data, so I can just type these things in directly. So this is really the same, but it just looks different. Okay, hold on a second. Okay, that's an obvious problem because I forgot I did not name it that. There we go. Okay, so that's fine. And I need my labels. I'm just going to make up different labels to save time. And whoops. Well, it would help if I still did this. Okay, great. And I'm not going to bother putting, I guess I will put a title. My table, my labels, and then main equals age. But see, I like this a lot better. For some reason, on this computer, I get much better graphics, bigger graphics, and where they put the text makes more sense, the size of the font makes more sense. So anyway, if you really like R, then I would suggest you put it on your computer because it's free. And you won't have to, well, I'll talk about libraries in a second, but you won't have to reload all the libraries quite as much. It would just be easier. So if you like R, even if you don't like R, you might consider just getting it on your own laptop. Okay? So you can see like this teeny little picture was, you know, kind of hard to read. Okay. Now what if I want to do some random pulls of something? Random normal, and I'm going to do 10 draws from the random normal distribution, but I'm going to let the mean be 100 and the standard deviation be 15, and it's just going to make a random pull for me. I could just put this somewhere if I want, or I could just look at it, whatever. Okay, now we're going to go ahead and recode the variables. If I want to recode the variables, then I need to pre-fill a box full of nothingness. So let me just show you over here. Well, I guess it didn't do anything. Oh, because I'm not looking at that anymore. There we go. See, I made a box full of nothing. A column full of nothing. And so now I'm going to go back and fill it. Okay, so now I'm going to say data, gender. Hold on a second. Okay, so I want to make this when male is equal to 1. I want to put the word male in that gender column. And then when we have male is equal to 0, I want to put female in the column. And you could see that filling in as we did that. So this is nice. Like, unlike SAS, we can actually look at our data as it's changing. All right. And a lot of this I'm not going to go over, but I do want to talk about subsets. You're going to need to make subsets for your homework. So now that we have gender, we may as well go ahead and use it. So if you forget, like I always do, if you forget to put the comma here, you're going to get an error. You have to put this comma in. I'm just putting a lot of space so you can see what I'm talking about. You need that comma. All right, because it's telling us essentially rows, it's choosing rows and columns. And in order to choose all the rows, so this first part tells you which columns you want, and this part tells you which rows you want. And if you leave it blank, then it chooses all of them. That's what it's doing. So if you don't put the comma, you're just going to confuse the software. I don't know why, because I can figure out what I want. I'm surprised the computer can't figure it out, but the computer can't figure it out. So we have to tell the computer exactly what we want. Okay, and now I'm going to talk to you about so I'll use those men and women later, don't worry about it. So what I've done is I've pulled off 2 different data sets. So I've pulled off just the men in their own data set. Well, I guess I don't know why I'm not seeing it. Anyway, so I don't know how to view it. Let me see if I can make it view. Okay, you know what? Why don't I just do this? View men. Maybe view's the wrong word. Hold on a second. What word am I looking for? I guess I can't see the men. Guess you got me. Maybe I can't view them because I'm seeing the data. Can I view them now? Well, anyway, I can just type them here. So you can see I've pulled off the men in one data set and I've pulled off the women in another data set. So there you go. Okay, so back to what I was talking about. All right, I want to talk about packages. Packages. So you're going to need to use a lot of packages if you get into R. That's for 2 reasons. One is because R has lots of really cool packages. But the other one is because you can't actually do much in R without packages. So it's kind of a double-edged sword. Right, so if you're on your own actual computer, you only have to do the install packages step 1 time, and then it will be on your computer the next time you use it. But you do have to do this step each time. You have to invoke the library this way with the library command. That has to be done, but you have to spell library correctly. You have to invoke the library each time you want to use it. Okay, but because we're working on the VCL, you need to install it and invoke it each time you use it. So when you're going to turn something in for me, since I'm going to probably be looking at it on the VCL, I want you to go ahead and put the install line in there even though it might not be necessary on your home machine because you really only had to install it once. Okay, but now that we've installed the library psych, this is because I want you to be able to get quick summary statistics without typing everything in a million times. So this is just to make your life a little easier. Okay, so this is going to give you the range, it's going to give you the min and the max, the mean, the standard deviation, the median, everything except, let's see, you've got the min and the max, you don't have the interquartile range. But when I ask you to give me summary statistics on a variable, then you can just do it this way. You can use the describe by, but then you have to use that other command to do the 5-number summary. And so between those two, that takes care of your summary statistics requirement. Okay? All right, scatter plots are kind of interesting, and I want to sort of take this one step at a time. So we're going to do plot men, C, men, exposure, and then we're going to do that with women too, but we're going to let the men have the little black dots, and we're going to make an AB line. AB line is you're just going to connect some points. LM means a linear model, and we're going to do a linear model on the men exposure versus men, and that's the temperature. So that's pretty straightforward. It's just going to make a black line for the black dots. Now it's harder to do another color, so we're going to do the women in red. But before we do the women, I want to talk about this a little bit. So I'm going to just show you what this linear model looks like. So here's the linear model for the women. Okay, so we're going to say women. The same exact thing we just did for the men, but we're going to do it for the women. So what does this do? It tells us that we have a certain function call that we just used, fine, and it tells us we have an intercept and a slope. That's what's going on. Alright, so an easier way to ask for that information is coef of x, now that we've called it x. But what if we just want the first one of those? We want just the intercept, we can call it this way. And just the slope, we can call it that way. So we can extract back the slope and intercept from our linear model if we want. But we're just going to use it wholesale. I wanted you to know the anatomy of this command. Okay? Now, I want to continue adding to my current plot. So par stands for parameters, and I say new equals t. For whatever reason, that tells the computer to keep adding to the current plot. It seems like it should be f. I would say new equals f, but I mean, I didn't write r. So anyway, new equals t is going to keep us adding to our current plot. So I'm going to plot women C, which is current temperature, against exposure. But if I didn't change the color, I would not be able to tell the two sets of dots apart. So I got to give it a different color. And so now, you know, you can see this lovely mess that we've made of the plot. It's okay. When you're doing this for your presentation, you'll figure out how to keep that from happening. But it just decided to put the X and Y labels on the plot over and over and over again. So it's just kind of obnoxious. But there's ways you can keep it from putting the X and Y labels on again. But for now, I'm not going to worry about it. Okay, so now I want the AB line for the women. So I already have it. It's called X, and the color is red. There we go. All right, so I do want a legend on this, and I'm looking and I'm estimating somewhere like the X value is about 40 and the Y value is about 70. That's a good place to put a legend. So if you remember how much trouble we had when we were using SPSS of where we were putting legends, like they would just be all over top of our data. So I'm going to look for the blank spot up here, and I'm going to go ahead and put the legend right there. So I'm going to put the legend at, say, 40, 70, and that's, you know, that's the the position relative to our data, okay? So we don't have to worry about the actual coordinates. We're just doing the coordinates relative to our scale that's sitting there. Okay, that's nice. And then we need to put the legend, and this is a little bit annoying, but we got to type all this in, it seems like a million times. Make sure you get it in the right order. So we want women and men, okay, and the color is going to be red followed by black. You could do it the other way, but you just have to be consistent once you figure out what you want. So LTY means line type, so line type 1. CEX, it tells us about what font size we want, and I've tried this before, so I just like font size 0.8. So you're gonna have to explore your options and experiment with those options, but those are the ones I picked. Okay, now again, this would look better on a different computer, but I'm gonna go ahead, and one thing I can do is I could just make this a little bit bigger. I could move this over, and every time I move this around, it changes it a little bit. Okay, and again, except for the X and Y axis labels, it looks pretty good now. The more I stretch it, the better it looks. So maybe you want to just stretch it on your screen like that, and when it looks like something you can deal with, something you can live with, then you can go ahead and export the image and go ahead and say, fine, I'm going to just stick that on the desktop as a, whatever image format you want. You have different options here. Okay, but that's one way to control the quality of the graphics. But you don't have to worry about the size until you're ready to export it, and you decide then. That's fine. As you can see, it looks kind of like I don't even know where it went. There we go. But see, it looks kind of disgusting here. But that's okay. You can let the preview can look disgusting, and then you can just make it look nice before you export it. Okay? So I wanted to show you that. Okay, what else did I want to show you? I think you can do most of this yourself. I did want to show you confidence intervals because it requires a package, and I just want to make sure this worked for you. Okay, so I'm going to install packages rmisc, and dependencies equals true. In case we need to install anything else, so it may have to install a lot of stuff. So it's just going to find out if it's dependent on anything and grab everything. And then once we have all the dependencies installed, then we're going to say library rmisc, and it's going to load everything, and then you can ignore those warnings. You need to use CI for confidence interval. Do not use little c, little I. There's another confidence interval command that comes from a different library, and it's done with a lowercase. The one I want you to use has capital. I mean, if you can figure out how to use the other one, fine, that doesn't matter to me. I'm just telling you that the one I'm intending you to use is capital C, capital I. And so, and then it has this flag CI 0.95, and the other command you have to type out the word confidence. I mean, they're very, very similar commands. So I can do this for my data. I could do this for the men. I can do this for the women. So since we already have our data split, it makes it really easy to repeat a command once for the whole data set and once for each group. You just kind of use your up arrow key to go through your previous command history, and then you can change something and re-execute it. Okay? So one thing I have not been doing, which I expect that you will be doing, or at least maybe you'll go back and do it at this point, you're going to go back and say, oh yeah, what did I do that was actually useful? And you're going to say, oh well, let's see, this command was useful. I really want to save this command, right? So then you're just going to copy that, and you're going to paste it up here. Control V, you can paste stuff. So you're going to just go through and see some of it was just messing around, but some of it you really liked. And so maybe this little bit with the pie chart, let's go ahead and copy that. I'm going to paste that in over here, and you have to get rid of these little greater than symbols. Okay, and then I hit Control S and it saves it. So everything that I want to capture is going to go into my script file. Okay, and so you're going to cut and paste everything that's required in this list, starting with bullet point 5, which is your pie chart, your 5-number summary, your mean, standard deviation, all that stuff for each of your groups. You're going to do that, and your box plots and all this other stuff. And when you're done, just make sure this thing is saved. And you know, I'm wondering if you could actually run 2 instances of R at the same time. I don't know if you can. I'm going to try this. Maybe you can. Well, it's already open, so maybe it won't let me. Let me just highlight this and try running it again, see what happens. I guess no harm, though I guess it's not bad. You can probably just see if that works again. Okay, so make sure everything looks good before you shut it down. Another thing you could do is you could just rename this if you really want to. Rename it to TXT and just peek at it in a text editor and make sure. What? Oh, sure, whatever, I don't care. Okay, so that looks good to me. That's what I expected it to look like, and that's what I was looking at in the editor over here. And then I can rename it again. When you turn in text files to me, I do not care what the extension is. You can leave the extension as TXT or .r, I don't care. It's fine, I can change it. And I guess that's it. I guess that's, hopefully that's all you need. If you have any questions, let me know. I will be here to help.